Hey guys, I'm Lulu from Farrar's third period, and today I'm going to be showing you guys how to solve the free response 2003 number 1 from Calculus AB's AP tests. So this question is a calculator problem, and it says let R be the shaded region bounded by the graphs of y equals root x and y equals e to the negative 3x, and the vertical line x equals 1 as shown in the figure above. And it asks you for three things, which I will go more into depth later. So let's get started. A asks us find the area of R. Well, notice how R, its range, doesn't start from 0. It actually starts from this point to here, which is 1. But we don't know this specific point. So how do we find this point? Well, we use our calculator. I'm going to be using the TI Inspire CX. So you first go to graph, and then you graph your two curves, y equals root x and y equals e to the negative 3x. And then you go to menu, analyze graph, intersection. And once you click that, you can manually set your bounds by clicking to the left and right of the point. And it doesn't matter where you click, the point just has to be in the middle. And then it's going to tell you the intersection. Well, it says the intersection is 0.238734, comma 0.488604. And we only need the x value in this case. But notice how that value was extremely big. It's 6 digits long. And we don't want to be handling that value. What if we write it down wrong? What if we type it in the calculator while solving it and turns out we misplaced a digit? That's going to be a really sad reason for screwing up a problem. So we can fix this by first copy and pasting the value onto your scratch pad and then clicking variable. Scratch that. First click control and then click variable. So this will let you access the store option. So this arrow will come up and then you can write a letter down to represent this number. And in this case, I'm using T. And then click enter. And now it's going to remember T as that value. So now let's find the integral for our area. The area integral would always be integral from t to 1, our ranges, of root x minus e to the negative 3x dx. So for areas, you always do the upper curve minus the lower curve. And in this case, we know the upper curve is y equals root x because we know the rough shape of certain graphs that are important, like y equals root x. So we know that's the upper curve, and y equals e to the negative 3x is the lower curve. So we subtract this from this, and then we can plug into our calculator. So to do this, we go to this little book option and then go to the fourth tab and then select the integral option, and it'll show up on your scratch pad like this. So then you can just plug everything in. But how do we plug t in? Because you can't just simply type t from the keyboard. You first go to variable and then you click the one you want, which in our case would be t. So now, every time it sees t, it'll know we're actually talking about that really, really long number. So after plugging everything else in, which is self-explanatory, we get 0.44262999. And in calculus, you always round to the third decimal, so we would round it to 0.443. And that's our answer. Now the AP test will grade you like this. You would get 1 point if your limits were right, and you would get 1 point for your integrand and 1 point for your answer. Now let's do problem B. B asks you to find the volume of the solid generated when R is revolved around the horizontal line y equals 1. So we're revolving this R region around y equals 1. And if you can visualize it in your head, that'll make solving this easier. But for the people that can't, just think of it as you have the curve that's the farthest away from the place you're revolving it around, and then you're going to subtract the curve which is the closer to the place you're revolving around. But after setting in a certain format, you can't just subtract it. So what is this format? Well, it's going to be pi integral from t to 1 of 1 minus e to the negative 3x squared minus 1 minus root x squared dx. So what is this 1 for? Well, this 1 is actually our horizontal line, y equals 1. Because if we only had, let's say, e to the negative 3x squared, that's not going to give us the places we want. We have to subtract it from 1, or we have to subtract 1 from it in order to get this line that we want. So we're going to also do the same for the value closer to our line, our horizontal line, and we of course we have to square both of them. And note that this is the same as this, which this is, it's just flipped. Instead of having 1 in the front and subtracting e to the negative 3x, we're subtracting 1 from e to the negative 3x. And why is this okay? It's because we're squaring it at the end, so it doesn't matter what your value is, because once you square the positive or negative sign, it's all going to become positive, so it doesn't matter. So that's handy, and the AP test, they're okay with either choice since they're the same. So after plugging that into your calculator, which I'm going to assume you know how to do by now, and also I did it 2 minutes ago, you would get 1.423558, which is roughly 1.424. Now the AP test, you get 2 points for your integrand and 1 point for your answer. For your integrand, you're going to lose 1 point if you reverse it. You'll lose 1 point for an error with the constant, and you're going to lose 1 point if you leave out the 1 in the radius. And if you just do something weird, they're going to take 2 points off. Now for C. C says, the region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a rectangle whose height is 5 times the length of its base in region R. Find the volume of the solid. Well, to do these, we first find our side, which is technically our length in this case. We're going to be multiplying length times width, so to find our length, they tell us that the cross-sections are perpendicular to the x-axis, so they're going to look like this, or they're going to be arranged like this. So to find our value for this, we would get root x minus e to the negative 3x, which would give us all the possible values for these after plugging in an x. So now next, let's consider the shape they give us. They tell us it's a rectangle whose height is 5 times the length of its base. Well, the base is our s, our side, which we found a couple seconds ago, and we know the height is 5 times s. So to find the area of this rectangle, it's going to be s times 5s, which is 5s squared. And we know s, so it's going to be 5 times root x minus e to the negative 3x squared. And now we just have to integrate it to find our volume of the solid by cross sections. So when integrating, we would do 5 integral t to 1 of root x minus e to the negative 3x squared dx. And after plugging that into our calculator, we would get 1.554. And for these kind of problems, they may seem complicated, but the straightforward way to do it is just find your s, which is your length, and then look at the shape they give you and find the area of that, and then put your s into that, and then integrate the result, and that would give you what you want if you have no idea what you're doing, like me. So the AP rubric, they give you 2 points for your integrand and 1 point for your answer. And for the integrand, they'll take off only 1 point if it's wrong, but they still have the root x minus e to the negative 3x as a factor. So if you have your s right, they'll actually only take off 1 point. And that's it for me today. I hope this was helpful, and thank you for watching.